I wish the thing had like different music you can play than this elevator music. All right, we're getting to the top of the hour. So let's get started. For folks that have trouble kind of jumping on, the YouTube link is in the chat. Let me pull up our wonderful speakers. Let's pull our speakers. One moment while we get everyone. One more speaker, and we'll get started. All right, last speakers in. Uh, all right, everyone. Thank you all for joining us today. I always look forward to the end of the month because of these talks. Today, we have yet another stellar lineup with Sai, Riken, or Ken, and Arushi giving us wonderful presentations. These meetups would not be possible if it wasn't for our wonderful sponsors like Jazz, Electric Sequel, PowerSync, and Bella. And I want to take a moment to say thank you to all of them. First up, we have Sai giving us a talk on a very timely topic of local AI and all of the work he's been doing with getting agents running with Rust. For those that don't know, the sort of candle library by Hugging Face is like Rust backed and has a lot of bindings to Python and all of those. And I give him props for choosing the hard part of machine learning. And recently, Quen 3.5 dropped March 7th. That was a step change in the model capabilities. A $25 billion parameter was already outperforming Sonnet 4.5. And for those that didn't catch the Turbo Quant news, there was like a KV cache compression system that got released. The paper apparently was out a year ago, but it just makes the same identical like inference for 1/6 the memory cost of RAM. So these are all really exciting times. People are raving about buy GPUs again. So on that note, I'll hand it over to Ken, uh, Sai, and have him kind of break it down for you guys.
Yeah, sure. Thanks a lot for the introduction. Yes, Quen has changed a lot on what we can do with the local stuff. Yeah, I think my screen should be visible now. Can anyone give me a thumbs up?
Uh, yep, it's loaded now.
Awesome. Yeah. So hi everyone. So I'm Sai Vishwak, and I'm leading this open source effort on building the agent first, like local first agentic AI. So I'll start with like my problem that I had with using this LLMs, cloud LLMs and all. So back in the day, like 1.5 year to 2 years back, I bought a 4090 when it was just released there. What I wanted to do was like I wanted to go into deep neural networks and actually train learn how this LLMs and all these transform models used to work. So I was very interested in that. Then I was like, okay, so these cloud models were coming up, OpenAI was there, and agentic systems were getting up. So I started in this systems when it was more of like LLMs, and then you got LLM workflows. So you stitch couple of agents together like a workflow, and you gave a couple of tools to them, and it became a workflow, right? Then you started moving into more agentic workflows like memory tools, React prompting, and all those things came up back then. So my main, curiosity was like, what if I could run this on local? Because I always had a bottleneck on like the costing of these API calls, right? It was huge because if I had to do any experimentation and all, it used to cost me a lot. So I was like, why can't I run these models locally? And there was a
Sai,
shift also happening. Yeah.
they're asking for you to like make your slides full screen or like there we
Yeah.
go. It's
Got it,
harder
got
to
it.
read.
I got it. Oh, okay. Good. Yeah. Thanks for that. Yeah, so I always wanted to run these agents locally, and my vision and dream is to actually, have an agentic robotic system. That was my vision, and also an local first operating system. So the grand vision was like, see, what if I had an operating system which was more of like an agentic in nature, like I could just talk, get my work done, and everything, right? But there was a huge problem with this. Like if I only use cloud providers whenever there's no internet and all these things, it's not going to work out, right? And it doesn't have a good user experience. And second is privacy. If I'm going to rely my whole life's data and everything on these systems, I'm never okay with giving those data to these providers. And obviously, I know that it's going to be again used for training and all this stuff. So that was a big no for me. So then the problem was like, how do I make the system work locally? So there was a small shift happened back then, like 1 year back around September or in that time frame, 2025, where Tiny Llama came up. It was a 1 billion model, which was actually doing pretty good. Back then, it was a decent model which came into the local first, like 1 billion parameter, which was doing good, and people could actually who can run these things. So that was made specifically for the edge. So that was a turning point. Till then, it was like you can use LM Studio, you can use VLLM and all these to serve models, but you had to have a good GPU, right? You need to at least have a 4090 or bigger GPU systems at home. So what if we could actually have a small mobile, which is already there with most of us? How can we run these LLMs, right? So that was a moment that I was like, okay, we need these agentic AI systems which are running already on existing devices because we can't expect users to buy new devices. Like I can't expect a person to go ahead and buy a 4090 just to use an agentic AI experience, right? So it also needs to run on existing devices which had a decent amount of RAM and memory bandwidth. So then I was like, okay, so to do this, what is the thing that we have to start with? So first is the agent framework. So I wanted to go ahead and look into the market, like what agent frameworks were available to build agents for edge. So if I say edge, that means like it should be embeddable directly into any other program. It should not be like I run a VLM server separately or an Olama server separately and then just run a LangChain agent and just talk over server, right? That was not the use case. The use case was like, I need a single binary or a single package that I could directly use it to run without hosting a server and all, because I need this to be embedded in a different application as well. Let's say I'm building a desktop app. I want the package to be directly used, and it should run the local model as well using GPUs, like if it's CUDA, Metal, or any other GPU accelerator as well. So that was the use case. So I looked at the market. There were none actually. There were no major frameworks that support that kind of packaging. So I was like, why not build one for ourselves, right? So that's when I started with this project of auto agents. So auto agents is basically a local first agentic AI framework. It's completely built in Rust from the ground up. So it has a very modular approach, like what an agent is. It's very opinionated in that way. In sense, like agent has three things which are important, right? One is an executor, one is the memory layer, one is the LLM layer. So agent is just a combination of these three things. And auto agents has specifically architected in such a way that you can swap any of them at any time you want without changing the other layers. So LLM is just a layer, and memory is just layer, and executor is just layer. So it's modular in that way. You can just swap up any of those things whenever you want to. So that was the thing. So this was the current problem in agentic systems that I saw. It's like enterprise security is not there because cloud APIs you can't use in regulated industries with the cloud, right? It has a lot of data leak and all those issues, and you also had infrastructure fragmentation, like you had to run a different server for running these models and all these things, and you cannot directly embed them in robotics or small edge use cases. So that was a bottleneck. So our framework actually tries to solve those kind of systems. Like, okay, so our main philosophy is like, write your agent once, deploy it anywhere. You can either deploy it on your mobile, or you can deploy it on your Mac OS application. You can deploy it as a server. You can deploy it as a robotics application as well. So that was our main idea. So that's how we started with this whole project, and we are progressing on those fronts. So I'll go through on the parts of like how it actually works on like internally, what is the actual architecture for us. So first, as I mentioned, the agent, right? So you have an agent. Agent is nothing but a combination of three things. So if you see here, you have an agent here, simple agent. So agent is a combination of memory, LLM, and I think I have to use the font as well. Yeah. So you have an agent which has an LLM provider, a memory provider, and your executor, right? So if you see here, you are using a React agent. React means the philosophy of like the loop philosophy, reasoning and acting. And then you have the LLM, you have the memory. Three are decoupled. Now, if I want to use a local LLM, right, it's a matter of fact of just using this with a Llama CPP backend. So we support Llama CPP and Mistral RS backends for local models. So I have an example that also runs Llama CPP, and I will show you exactly what it looks like. So if you see, right, we have a provider here, Llama CPP provider, and you just give your repo ID from Hugging Face for the GGUF model, and it just builds the LLM provider. And it's a matter of fact of just hooking that LLM into a agent handle. So we go to the agent. If you see, the LLM is the same LLM there. So the idea is like you just build this agent even with a local provider, it directly runs on your hardware. So now you can actually compile it into a CUDA version or a Metal version or even Vulkan and all these different accelerators which Llama CPP provides. So this is the advantage we had. This was the main power because now I could actually, instead of relying on a Llama CPP server or again a different service that hosts my local models, I could actually package it as a direct application, as an agent application, right? So that was a breakthrough for this project that we did. So now what it enabled us to do is like, I'll show you the recording that we had. So this is an Android application. It's, if you see, it sits on an airplane mode, and I'm loading the Llama 3.2 1 billion model, and it runs natively on this device. And you actually didn't have to do a lot of rewiring, right? Because it's Rust, it's written in Rust. So I could just compile it into Android. Because Android supports a decent amount of Rust, right? It's very good with Rust. So I just need to write my C kind of bindings on top of the Rust project, and I just can run it directly native Android. And Llama CPP actually has a very good accelerators as well back in the behind the scenes. So it runs very well there. This recording has very less tokens per second speed, but actually in the real demo, if you see it has a very good decent tokens per speed. So I have this example. So let's say I'm running the same example that I showed in the previous code, right? So if you see, I'm just running this and you, okay, so I got some error here, but it will run the same Llama CPP server and it will actually execute it. So we also have a Mistral RS example. I'll run the Mistral RS example. So Mistral RS and Llama CPP both serve a different purpose. So Llama CPP is very good for the end edge application, but Mistral RS is good for kind of like you have multi GPU systems and you want to do distributed computing there. Yeah. Meanwhile, when it's compiled, we can just go through our repository. So this is the first attempt that we did for local first agentic AI. So now you can just run your agents, deploy your agents using Rust and local first philosophy. And you can actually, but now the second is like, how can I actually make it a worthwhile, like, let's say we use Claude Code, we use open code, we use a lot of other agent harnesses, right? So the idea is like, we in the future, we want to have these agent harnesses. But obviously, Cloud Code is not going to support local first runtime because the main revenue behind Cloud is their API usage, right? And the same thing for even Codex as well. And open code is very good. It's a very good open source project, but open code to work on local models, again, you have to run the Llama CPP server or some other uh, service, right? It cannot be directly embedded into a different application like a robot or something. So if you want to have a true agentic robot, your binary should be running on the robot, which already has a LLM backend baked in. That's what the idea is. So for that, what we are trying to do is we are trying to build an agentic harness kind of solution where you can actually package your agent bundles, and this agent bundles can be run across hardware. Like agent, I'll explain you what an agent bundle is, right? So agent bundle is nothing but it's a manifest with an agent variable specification written. So this is an agent. It has a prompt, it has a model, and all. Here you can also run your local Llama CPP model because it's built on top of auto agents. Okay, so it's built on top of auto agents, so I can run even my Llama CPP server directly. So now you have this bundle, and this bundle has a lot of good things. Like it has sandboxing capabilities, like what file system to be baked in, what tools to be baked in, and what skills to be baked in, and everything else. So this allows at build time for me to compile this whole agent bundle into like an OCI compliant artifact, and I can just share it across my hardware and run them in my agent harness. So that's the second layer that we're tackling, because we want, at the end, we don't want users to go ahead and build their agents again using auto agents, right? If I really want to change the way users interact with local first agents, I want them to be like as simple as just using a Claude code, but again works directly with directly with this local systems. So for that, we also have this TUI which we have, and this TUI works directly, with local models as well. So it's an agent harness, the same bundles that I've showed you earlier, that you can install those bundles, and those bundles will work in, and you can actually run local models with this agent harness because it's built on top of auto agents. And the advantage you also get is you can do routing, right? Let's say local models are not as good today. They'll be very good in, let's say, next 3 years. But what about today, right? We need to also serve today's people. For that, what we are trying to do is a layer of abstraction where you can actually do routing. So whenever, whatever task is required for local, we run it on local. Whatever is required for cloud, we provide it to cloud. And there are different strategies for that. One is like performance optimized, one is data optimized. In performance optimized, obviously, I would make sure more tokens are used on local and less amount of tokens on the cloud. But if it's data privacy, I would make sure that my routing happens strategically. Okay, this is a sensitive data that needs to be run only on local. The other some non-sensitive data can go to the cloud, right? Those kinds of lot of cool things can be done. So that is what our final vision, and we want to serve people at the end, because my aim is to build an operating system with agentic first operating system, and that from the beginning is local first, because I don't trust any cloud providers with my data. So if I want to go completely offline, like I want it to be working anywhere, I want it to be having local. Local is not a feature for us. It's actually it's a methodology and a philosophy that we follow than as a feature. Yep.
Awesome talk, Sai. I don't like personally. I like this idea of a two-step model. So the like read all of the files that I have, messages, texts, and everything locally, but then only like upgrade to cloud with a more like pseudo-anonymous kind of setup. Uh, and if you stop sharing, we can proceed to the next one.
Yeah,
You
sure.
finished your talk, right?
Absolutely.
Okay.
Yep. Yep.
Thanks again. And I have a few questions for you at the end of the sessions. What we'll do is we'll usually
Yeah,
like
absolutely.
stop the recording and then have like a very uh, open form living room chat. All right.
Yep.
After that wonderful local AI and local agent talk by Sai, we're going to jump into memory problem in local first with Ken. So this is a nice segue into how people who actually have shipped products used by 700,000 people have had to think about sync local first and some of the learnings behind it. Me and Ken grabbed coffee in SF recently, and it was like wonderful to hear about all of the work he's done. All right, over to you, Ken.
It was a good time. Thank you so much. And I really believe what size building is the future. I do believe edge computing is the future in near real time. So yeah, let me share my screen and let me know if it's working. Can you see my screen?
Yep, you're coming in great.
Perfect. So yeah, hi everyone. I'm Rikan, and today I want to talk about the like somewhat under discussed area while building a local first app is how do you deal with large data set without without breaking your device client. Like how do you take care of large data set on your local first app? So why I'm talking about this? I was recently building a local first app on the web, and I was able to reduce the footprint by 90% in my newer architecture. So my previous architecture was taking 545 MB to load the same data set, and now it is taking 44 MB. And I was able to reduce my time to interact to from 7.6 seconds to just half a second. And I want to share how I did it, and I'm pretty sure it will be helpful to everyone. So before moving forward, I just want to set a premise. So this is how my app works, and I'm pretty sure a lot of local first app would have a similar architecture. So it's a very simple thing. Your app, your client would request data from the server. It will first get all the data. It will persist in some kind of data store. And when we have to hydrate the UI, we will load that into the RAM and then we'll hydrate the UI. And there's an incremental process where it will ask data for again, it will store persist in the disk and then load again. So how I got here. I joined Task 3 years ago. Let me give you a little bit introduction about Task. So Task is a productive Kanban app. It is available across all your Apple ecosystem, your iPhone, your Mac, your watch, your Vision OS, everywhere. And it is used by non-tech savvy people. Imagine your grocery local grocery store owner running his business with 5 to 10 people. They use Task, and Task is nothing but just all your tasks in a beautiful Kanban board where you can scroll through different tasks and see what's happening. And so I joined them 3 years ago, and and we didn't have any sync engine back then. We were using CloudKit, but I was tasked to build a sync engine. I built a sync engine completely from scratch, and today it's completely stable. And if you guys, by the way, if you guys are interested learning more about the sync engine, I've written 2 articles, so please do give it a read if you guys are interested. It's on my Twitter. And I was recently tasked to build a web version of tasks. And it was a very wonderful experience. I got to learn a lot of things which I wanted to share with the community. So in my initial architecture, when I was testing with different like mock data, it was going very good. With 100 tasks, it was going good. With 1,000 tasks, it was very smooth. But when I hooked it up with real data, and one of my project had 10,000 tasks, my app started to feel a bit janky. When I was scrolling, it was not as smooth, and my initial load time also increased a bit. And when I switched to my even bigger project where I have 100,000 tasks, my app completely froze and it crashed. So there are four, after learning a lot more about this and doing investigation, I found there are four things that I have to think about while building app which will scale well with large data set. And it's not only limited to app which you are building on the web, but any local first app that you are building. So there are four walls I hit. The first was memory. It's very obvious. I can't keep, if I have data ranging from 1 to 2 GB, I can't keep everything in memory. So this is what I hit. So if you look at the if look at the app, there is not just one thing associated with task. So I have the task title, I have date, I have all the metadata associated with the task. So with that, we have also been using observable libraries and all the libraries under the hood. And I did a rough math, and I was able to figure out how much each task card which I render will cost me. It was coming out to be 14 kilobyte. And when I multiplied it with the number of tasks that I would have, I was shocked. It was just taking 350 megabytes of memory when I was loading just one project. I was loading entire project data when user loads just one project. And it was not a very good solution. If I have a much bigger data set, like much bigger task data set, it would just crash. The second problem was DOM rendering. I was very chill with this, that I didn't thought about the DOM load that it takes on the browser. So if I have 10,000 tasks, I was rendering 10,000 nodes in the browser and then lazily loading all the data, which was still it was still preserving memory, but it was still causing a lot of DOM rendering expense at the browser. So I deep dive into this, how DOM rendering works, and there are a lot of things going on. So DOM is essentially a tree, and when I have lot when I it has to construct a tree, and with after that it also has to do all the style recalculation, that is CSS in the play, and after that. After all the interaction, after you scroll, after something happens in the browser, it executes a layout reflow every time. So it's not a very ideal state that you load 100,000 nodes in the DOM while you have 100,000 tasks. You have to be very smart about it. And third, and the most important thing that I learned was mutation handling. So before in my initial architecture, if any change comes from the server, for example, someone updates the task or someone changes the date, I was requiring everything from the disk, bringing that into memory and recomputing that. That was not a very good solution. And this was happening because I was using a DexiDB. DexiDB is just a very beautiful wrapper over IndexDB. IndexDB is a very beautiful database solution for the web, but the only downside is that they don't provide any library or any event handler where I can look for any change happening to the database. So because of this, I was retriggering the query from the disk, bringing it to memory and recomputing everything, which was not very good solution. And the fourth topic that I talked about, fourth point was storage speed, which I'll talk about later. So, like everybody else, I went into research mode, and there are three solutions that I found, which was like very talked about for this problem. The first was pagination. Pagination is nothing but breaking down your large data set into set of batches, and user can click on that page and head over to the next set of data. You have seen Google using that at the bottom. So pagination, while it's a very good solution, and I use that while I build the API for this, but it is not a very good solution when we look at from the user perspective. I don't want user to click second, third, fourth while they are scrolling through their tasks. And the second solution was virtualization. It is a very good solution where it solves the DOM rendering problem, where I don't have for if I have 100,000 elements, I don't have to load 100,000 DOM in the browser. I can just reuse 1,000 DOM elements, and then as users scroll, I can recycle that to load another data. So it creates a virtual scrolling experience where I can reuse all the elements and like avoid creating 100,000 elements for 100,000 tasks. While it was a very good solution that solves DOM and UX problem, it was still I still have to keep everything in memory so that user experience doesn't break. The third approach was windowing, which was very closest to what I wanted. Windowing means you only load what is essential to you. So if I'm seeing this snapshot of the screen, I will only load all the tasks and all data relevant to this screen and not anything below or above it. So this way we scope what we load into the user memory. This was a very clever solution to memory where if I have 100,000 tasks, I wouldn't load all the tasks at the same time. I would only load the snapshot of it, what is user seeing in the screen. And the second thing it solved is DOM. So I only have to use this part of DOM elements and I can recycle a lot of DOM elements as users scroll. So while it solved two problems very nicely, there are still two more problems left. The first is, as I talked about, is mutation tracking. I don't want to requery everything from the disk and recompute every time a small change has been happened in the origin. And the second was a fast random access memory. So I did a lot of benchmarking with IndexedDB, and I found that it doesn't scale very well when I have a lot of data. So to solve this, I built Entity Store. Entity Store is a memory engine which sits between the UI and the data store, and it handles memory entirely for you. And I want to give you an analogy of the garbage collector of any programming language, any high-level programming language. Like a garbage collector, my entity store would look for the data which has not been used, and it will automatically unload them from the memory and keep memory very lean as we scale. So how this works is very similar to windowing, where I will only load all the relevant data which user is seeing on the screen and unload everything else. So and while this solves memory and DOM problem, we still have mutation handling problem. So to solve mutation handling problem, I built observable queries. So what do I mean by observable queries is that, for example, I have to load this part of the screen. If you can see, it's a projects where out of all the projects. So what it will do is my UI component will send the query of all the tasks that it needs to access to my entity store, and my entity store will get all the relevant indexes of this projects into the memory and send it to the UI. And with the help of intersection observer API that browser gives, I can now see what is visible to the user, and I will load them instantly in the memory. So, and as user scrolls, I can remove those projects from the memory and keeping it free. And with this, I also set up buffers. So when users scrolls to the next section, there is no delay and it is already loaded. So yeah, and with the help of like observable queries, it solved one more problem where if any new data comes in, for example, someone changed a project title or someone changed something about the project, it doesn't have to requery from the database. So I have an interception happening before dumping the data in a database. It will automatically update the object model on the memory and reflect in the UI. So this way, I only query once and then it will handle all the mutation afterwards. And to solve this completely, I used Mobax. So Mobax is a very good library. It's a state reactive library where I can convert, like it's an observable library, and I can convert any data into observable. So for example, I have an object of project. I can make it observable with the help of this. And this way it creates a bottom up architecture rather than top down architecture, which generally React has. So I'm using React, and in React, rendering happens to the parent component first, then it goes down to child component and to that component. Well, this was a very good solution, but it still was causing a lot of layout reflow. So to solve that, I build a bottom-up approach where, for example, this task has been updated someone by some other user. I'll get that change, and I will have that loaded in the memory in entity store, and I will make the change in the entity store. And as soon as I change anything in entity store, all the updates will reflect in the UI. So yeah, and I found out about this library through Linear. So kudos to them. I was reading how Linear is handling their stage management, and it's beautiful. So with help of this, I solved somewhat of mutation handling problem where I was re-rendering and requerying every time. Now I'm not doing that, and I have a granular observability for each component in the UI. So while all of this solve all the three problems, to make it live, to make it to the production, there's still one big problem is that index database doesn't scale well when I have a lot of data and I want to randomly access the data from disk to the memory as soon as user is about to scroll to them. So I did a benchmark and it was very bad for IndexedDB, and I was looking for a solution apart from IndexedDB, and I found that I can actually run SQLite with the help of WebAssembly. So I tried that. I ran SQLite through WebAssembly and used like users private file system. So browser has this API where I can access their private file system directly, and I was shocked. So well, I run the benchmark for both of the things, and I found that SQLite using OFPS is 4 times faster when I want to randomly access the data, and writes are even 2 times faster. Well, this solved the scrolling and the writing part, but sequential read in this case index database win. So I thought why I can't use both the things. So I built a hybrid model where I'm using IndexedDB and SQLite both. So as soon as a UI component register a queries, we load all the relevant indexes to that query from the index database. So, with that, UI will register the component, and with the help of intersection observability API, I would load all the things which is relevant instantly from the SQLite. So this way, we are using best of the both worlds, and it scales very well. So now about the numbers. So as I told you, I was testing this on the same dataset size and with the same data. And in my initial architecture, it was costing me 545 MB of RAM. And now I've reduced it down to 90% to 44 MB. And my time to interactive is also very good. It is just half a second. So now I can actually ship this out to all my users. And I didn't stop there. I benchmarked it even further. So instead of 25,000 tasks, I went to 100,000 tasks. And the result was as I expected. It was my second architecture was very lean memory wise. And the experience doesn't change a bit. And yeah, while in my initial architecture, it was costing me 3000 megabytes of RAM. Now it's just taking around 100 MB. So this is the actual thing that I can ship, and I don't have to worry about for few years when the user data scales. So yeah, now I just want to give a live demo of what I've built. So this is a benchmark tool and it's live by the way. So if you guys are interested, you can head over to web the task.apps/scale and you can try it out for yourself. So this is my initial architecture where I have 25,000 tasks loaded. And as you can see, it took 4 seconds to become interactive. And as I scroll, it is taking a lot of time. And currently, it is holding around 437 megabytes of memory in the RAM, which is not a very good thing for 25,000 tasks. And this is my current architecture. As you can see, it loaded very quickly. Around it took 135 milliseconds to load. And as I scroll, so and I just want to show you the heap memory. It's right now 200 MB. And as I scroll, it stays very lean and it loads everything very instantly. So this was the experience that I was looking for. And yeah, even if I go up to 100K or 50K, it stays the same. And if you guys just want to try it out, we are very happy to try this out too. And yeah, this is my thing. And I just want to live with just one thought. So if you guys are building a local first app, this is not an immediate problem that you will see. As your app becomes more mature, you have more users using your app, user would accumulate this data eventually. And you will hit this four wall some way or another at a different scale. So if you think about the memory thing beforehand, I think so it would save a lot of time and user would have the best experience every time. And yeah, if you guys have anything interesting to talk about, I'm happy to hop on a call and discuss. You can DM me on my Twitter. Yeah, thank you. Thank you for your time.
That was an awesome talk, Ken. And like it's
Thank
basically
you.
like should be extended to just all React development in general.
Yes.
Uh, did you ever run into Legend List, by the way, Legend List and Legend State while you were um, investigating observables and MobX? And I think Superhuman also uses MobX.
I didn't run into Legend, but I did a very deep dive with MobX. I was very picky if I should use third-party library. So in all of this, while building this, I have not used any third-party library. Everything is written by Claude and me. But yeah, I think so. MobX was the very good choice. I love how they are very unopinionated, and I can maybe in the future, if let's say if I want to move away from React to some other library, Vue.js, something like that, I can still use MobX.
Got it. Got
So
it. Wonderful. Great talk.
yeah,
Next up,
thank you so much. Thank you so
uh,
much. Yeah.
next up, we have Arushi. For folks that don't recognize the guy in that picture, that is me and her as SyncConf 2025. Uh, that was an awesome talk, and I've linked it into the announcements. And we'll have all the speakers put up their slides if it's possible in the announcements too. She spent years at Figma, just came back from Atmosphere Conf, and I can't wait to hear what she's cooking up with Habitat. Over to you, Arushi.
Uh, Yeah, Ken, there was definitely a lot of the words observable query brought back memories for me, for sure. Okay, let me just double check. Okay.
Coming in great.
Okay, can everyone see the slides?
Yep.
Cool. Yeah, hi, I'm Arushi. I am the founder and CEO of Habitat at habitat.network online and also on Blue Sky, not on any other socials yet. And until about a month and a half ago, I was working at Figma on our live graph team, which worked on one of our sync systems to enable real-time collaboration at Figma. So we did a lot of things with like everything outside the direct canvas itself. So like sharing like comments, yeah, everything outside the canvas. And yeah, I quit my job at Figma basically to work on this thing called Habitat, which is trying to bring user data agency to the web. And it's built on top of this protocol called App Protocol, or App Proto for short, which came out relatively recently. And I think it provides like a lot of great primitives in general for the web, but also that the local first community could really benefit from. So I'm going to be talking about the power of App Proto and local first software together. Okay. So these are like the 7 local first principles that the initial local first software essay from Ink and Switch came out with. And in this talk, and I guess in my work in general, I'm really thinking about these last 2, privacy and user control. I think there's a lot of good prior art for like these first 5, especially these first 4. But I think some of the local first work and principles fall short in like these 2 categories. And I think App Proto can help. So a quick introduction to App Proto for people who don't know. It's a protocol. It stands for Authenticated Transfer Protocol, and it's spun out of Twitter. Originally was incubating this, and it was called Blue Sky within Twitter, was the team working on this. And when Twitter got taken over by Elon Musk, the Blue Sky team spun out into its own public benefit corporation. Um, and App Protocol was really designed with like this big open social network case in mind. So like how can we give users agency whenever the platforms that they're on start inshittifying? And their goal was to enable decentralization by having multiple interoperable providers for every part of the system, make it easy for users to switch providers, and give users agency over the content they see. The the work that the Blue Sky team and the ecosystem has done for App Protocol has come out of a lot of other work that went on. So like there's a lot of people there who used to be at Protocol Labs or other similar peer-to-peer decentralized tech places. Okay, so the key concepts in App Protocol, and because it's only a 15-minute talk, I'm not going to get super technical. But some of the key concepts are this idea of interoperability between service providers. So a service provider could be something like a feed generator or a personal data server, which I'll get into later as well, or this idea of app views, which is someone who provides, or like a server that provides that application experience for using data from many users. And in today's stack, like in the traditional web, it's kind of this like vertical silo. So like one company or platform like Google or Facebook or Instagram is going to provide all of these things. App Protocol kind of tries to break that apart so you can have like a different provider for each part of the stack, with the goal that this is actually better for users. Another key concept is shared data schema language. So if I have an app that's doing like, let's say microblogging like Twitter, and then someone else has an app that's doing like Substack or newsletter, they actually know what the data looks like for each other, like the shape of the data. So there is kind of this opportunity to now pull data from separate contexts. Okay, user data portability. So if I switch from, say, there's not like another Twitter, but say there was like two Twitters, like Twitter 1 and Twitter 2, that are two different platforms, I should be able to switch between them without losing all my data and starting from scratch. And this is kind of built on top of the idea of decentralized user identities, and these are known as DIDs. It's a concept that was along like before App Protocol. Okay, this is like a really complicated diagram. It's directly from the white paper where App Protocol was introduced, but I'm gonna show this simplified diagram that I made. So how things generally work in App Protocol is that users have a PDS, which is short for personal data server. So every user has this like conceptually separate personal data server. It can live anywhere. It could live in your home, live in the cloud, wherever. The next part of the stack is something called a relay, and relays crawl PDSs. So they could crawl like some portion of personal data servers, they could crawl all of them, and they're basically looking for updates, so what's changed. And then they spit all of this out into something called the fire hose, and that's just like all the updates from a bunch of users in the system coming out at once. The next part of the stack is called the app view. So this is usually what app developers directly make. The personal data server and the relay is part of like kind of general infrastructure that is like known to exist, but usually if you're building an app in App Protocol, you're building an app view, and that's both querying user PDSs to get data, but also ingesting all the updates in order to index data, serve real-time updates, things like that. So client apps will connect to an app view to get their data. And one thing that to notice here really is that this stack is kind of agnostic in a lot of ways to what type of app you're building. Like you could imagine the first reference app that App Protocol came out with was Blue Sky, which is a microblogging Twitter alternative, but there's no reason that this kind of structure or stack shouldn't work for many other apps. Yeah, and like one really key affordance that App Protocol gives us is this idea of the everything account, a term that was coined by Anuj Ahuja. And the idea there is that you have many apps or ways of interacting with your data. So these are all, if these names don't look familiar, these are all apps built within the App Protocol ecosystem, but there's like multiple microblogging apps, there's like multiple long form blogging apps, many video apps, but they're not siloed. So like Blue Sky's data isn't living on Blue Sky's servers for the user data. It's querying directly from your personal data server. So in the sense, users kind of have like one account for everything. Okay, so I think that Ad Protocol gives local first two missing pieces that it kind of like almost like desperately needs to go mainstream. And I think these two pieces are interoperability and user-owned servers. And they go, when I'm thinking about these two missing pieces, I'm thinking about the two principles I talked about earlier, user control and privacy. In order to like get a hold of those and actually use them with local first, I think we need these two things. Yeah. Okay, so what do I mean by interoperability? In the Ad Protocol ecosystem, they use this term credible exit, which means users can leave a platform without starting over, essentially. So like the exit from a platform is credible, but more simply, it just means this idea of switching apps for free. So when I think about this in the local first context, one thing I noticed is that local first does give users more control of their data, right? If you are using Obsidian, for example, all of your Obsidian data is stored locally. So if Obsidian goes down or something, it disappears, you still have all of that data. And this is great, but it actually doesn't go far enough because the way a user interacts with their data is through applications. So another application needs to now be able to like use that data. And you can do this, like apps have like import and export types of things, but there's no just local first software doesn't give us like a framework to like do this collectively, basically. So it still has this kind of lock-in problem. So it's hard, for example, to switch from like Obsidian to Anytype to Google Docs. Ad Protocol has this idea of a shared data schema language, so a way to define what data looks like. So Obsidian could have something like a obsidian.doc, but then that can easily be transformed into maybe like a shared schema that's called standard.doc, which can now be parsed by Anytype or Google Docs. So in this sense, there like would be no import or export in order to switch from different document editing apps, as long as they all know about the existence of standard.doc, which is like would be a public data schema. It's basically for free, users can switch. And this kind of changes the incentives for developers building the ecosystem, but it's a really, really great property for users to have because it increases the user choice. Okay, cool. And then another property that interoperability gives us, which isn't directly related to local first actually, but it's this idea of infinite remixability. So this video here is from the Atmosphere conference page, and this website was pulled together in basically like a week or two, and it has like the live feed from Blue Sky about people working on it. It has a live feed from Leaflet, which is like the long form blog publishing. You can click into conference people's profiles, and no one had to upload a profile. It just like reads directly from your Blue Sky account. And I think that's also like a great property for users because it makes it easier for someone who's not as technical to basically pull data from a bunch of sources and show them. They don't have to create that data themselves. Okay, another affordance that the second big affordance that AdProto gives us for local first is user-owned data servers. So in the local first essay, there's this quote that's like, there is no cloud, it's just someone else's computer. And I love that. I think it's really concise and gets like to the heart of a lot of issues that we see on the internet. So this is kind of like the traditional world where in order for two computers to share data, to do anything with the internet really, they have to communicate over this shared server, which becomes a platform. And that platform now has like a data moat. It has lock-in usually. It's like someone, because you have to go through someone else's computer, that person now has like this power imbalance kind of over you. Proto breaks this apart a little bit by giving users their personal data server. These are user-owned. So an app view is kind of still like a platform, but it's a little bit less, I guess, like pervasive or all controlling. And yeah, this goes back to like the everything account concept I was talking about. So Habitat is actually trying to go, what I'm working on is trying to go even further than this idea that you have to rely on an app view to serve social experiences. So I think we all probably recognize this today, but this is what the traditional web looks like if Alice and Bob were to want to collaborate in a calendar app and also docs app. All of their data is stored in the cloud, and the calendar app and docs are different. Companies or platforms are broken apart. In Habitat, we are taking this idea of a user-owned personal data server, but trying to expand it a little bit. So, like, oh, we can't go back. Okay. Yeah, we're trying to expand that idea a little bit and say, like, rather than just the data piece being user-owned and some other entity trying to, like, pull all of that data together and serve it directly to users, can we give users their own servers, basically? So like a traditional data server just has a way to store JSON blobs and bytes in Proto. Can these servers now do like both those things, but also some primitive syncing, some like search features, some lambdas functions in order to make it possible to develop experiences that are local first and just rely on the PDS, the user-owned server, to do a bunch of like coordination and developer tools, basically. And yeah, the reason we're doing all this and like Habitat's vision for the internet is a few things. We believe that you shouldn't be followed wherever you go on the internet. The existence of like platforms gives rise to like a lot of poor dynamics, and the peer-to-peer field kind of in the decentralized field came out of like a response to that. We believe that you should be able to be highly contextual in your interactions. So for example, I use Slack a lot, and I use Slack at Figma in my workplace. I would also use it in like more like activisty or organizing circles, and then sometimes I would even use it with friends. But Slack is like built for basically a corporate workplace, and it it's like I don't interact with my friends or these like other circles in an office, but why are we all using Slack? That kind of idea. And then, yeah, we believe the things we do should be like human sized and human shaped. Today on the internet, a lot of things are either like huge global network, like you go to a platform with billions of users, or it's like a DM or like a group chat where everyone was like manually added. That's not really reflective of real life, where we like participate in communities larger than ourselves, but then we also have these like smaller enclaves. So we're trying to kind of like recreate that type of interaction or structure on the web. And our goal is to really reimagine the social internet by doing this. So we want to lower the barrier of entry for who can build on the social internet by doing a couple things. So building a functioning app should be as easy as creating a website. A lot of people can create a website. A lot fewer people can host a server and like maintain infrastructure. And I think that's going to be true even with AI. Developers shouldn't need to store user data in order to provide user experience, because again, that is going to make the group of people who are developing smaller. Like not many people want to store user data, even if it's like for their friends. Yeah, so we're trying to go beyond this, what the like norm is, I guess, in App Proto today, where there's like this platform that doesn't own users' data, but might need to like index it or aggregate it in order to serve experiences, and trying to say like, okay, what if every user owns both their data but like a functioning server with a lot of features? What would the internet look like? Our second goal is that building the social internet should not require sacrificing user privacy. So again, developers don't need to store user data to provide experiences, but also users should have transparency into their data. So they should see when it's shared with other people or apps, and they should have agency over their data. So if you shared something with someone, you should be able to cut it off in an easy way. And if you share something with an app and that app starts doing something you don't like, you should be able to cut that off. So I'll demo this a little bit later. Okay, and then we want to make the social internet a tool for group self-determination rather than top-down control. So if you think about the ways that communities organize themselves today on the internet, it's always on a platform. Like the Trader Joe's Moms group on Facebook is a Facebook group primarily. They're not like a group that exists outside of Facebook. So we're trying to invert that dynamic. Like, what would it look like if the Trader Joe's Moms group was like a group firstly, and then maybe they had some sort of app or experience that works like Facebook groups, like posting and likes and whatever, as a second principle. So one way I think about this is that I'm a part of this organization, Collective Action School, and right now we use like Zoom, Slack, Google Drive, the same things that I use at Figma, honestly, to organize ourselves. But what if we had a dedicated space for ourselves that showed like, who's in the school, what our syllabus is, a chat room, a video calling thing, and this was like a login to the Collective Action School website rather than going to different platforms to use that specific feature they give you. Okay, demo time. Yeah, so Habitat is kind of like a platform layer thing, but we're building some demo apps on top of it to validate what we're building actually works. So I'll do this from the beginning. So here I'm logged into 2 accounts. This is my Arushi Bandy.dot account. Let me make a new doc. LoFi.so.
Can anyone jump in and like drop the link if that's the case?
Yeah, the problem is that people will need an ad proto account to actually do this.
Okay.
Yeah, but I'll try to keep it quick. So yeah, we have this like real-time multiplayer markdown collaboration app that we're building, and this is my test account. So I can like add another person. Let's see if I refresh, this should show up here. Cool. And maybe like, yeah, so that's basically what it is. Pretty simple, but this is all local first. So we have like the user data servers, and we have like the basic app protocol one, and we built kind of like a sidecar to it that allows this to be built local first. If you tried to build this in app proto today, you would have to host a server. So like users would have to share their docs basically with a third-party server. And yeah, we're also working on this portal that I gave a glimpse of before. So to search your data for anything, see what apps you recently used, and this we haven't properly rendered like metadata about the data yet, but you should be able to see like literally each piece of your data, and this is the doc I just created. Need to fix this as well. But for everything that all the data you have, you should be able to show like who you shared it with. Cool. So I can see like all my docs and specifically who has access to them. Yeah. And I like genuinely think this can be the future of the internet. Um, I think app protocol and local first separately give us a lot of really great affordances and kind of like goalposts. And when we bring them together, they can be really powerful, if a couple of things are true. So if we kind of use this, Paul Frazee, the CTO of Blue Sky, has this blog post called Practical Decentralization. And I think if we use these two things together with like a practical decentralization approach where it's like, okay, we're not going to be a purist about doing decentralized everything. Maybe there's coordination servers, things like that. And then also, but also being an idealist in other ways. Like some people I talked to at the conference this week were like, yeah, like AppProto is great for big open social networks, and I've kind of given up on the dream of privacy online. I actually think these two movements together can like make that dream alive again. So that's what I hope for. And yeah, thank you so much for listening. I gave a talk that goes a little bit deeper into why we're building this weekend. It's called Rewilding the Internet with AppProto. I don't think it's up on YouTube yet, but it should be up soon. This is our website. If you are a developer who wants to build local first apps on user owned data, please get in touch because that's exactly what we're providing. And also, if you are or know someone who is interested in supporting this kind of work, please get in touch. Yeah, thank you so much for having me today.
That was awesome. This is a topic that is like near and dear to my heart. I've dedicated the last 5 years to basically take the internet, which is like content addressed and like platform centric, to user centered. The high context statement that you made of these, like the entity of the group of moms going to Trader Joe's surpasses just messages. Like could be like calendars and notes and receipts sharing and discount coupons and whatever. But since it's primarily shimmed in and organized around a Facebook group, then you have this thing of like the platform becomes the organizing entity as opposed to the higher order item, which is like just the shared community that wants to do X,
Yeah.
not just chat. I love it. I'm going to stop the recording now, and this is where we kind of just talk about whatever.